Number one, the radius of a sphere is r. The absolute uncertainty in r is delta r. What is the fractional uncertainty in the volume of the sphere? The volume of a sphere is given by V equal 4 third pi r cubed. We can find we can find delta V over V through modulus of the V dr times delta r over V like this. So delta V or V equal modulus dV dr, derivative of V is 4 pi r squared or 4 third pi r cubed times delta r. So delta V or V equal 3 delta r over r because 4 divided by 4 third equal 3 and pi divided by pi equal 1 r squared and divided by r cubed equal r this one. So this. So we can write things like this: delta V or V equal 3 delta R for R is 1. It's 1. Astronomers have measured that the magnetic fields of some stars are order 10 power 10 T. Physicists have measured the magnetic fields of some laboratory magnets to be 1 T. The types of uncertainty are absolute uncertainty, fractional uncertainty, percentage uncertainty. What types should the groups use to compare the precision of their measurements? Absolute uncertainty, since the measurements of magnetic fields for astronomers and physicists are on very different scales. For example, 10 power 10T for stars and 1T is for stars and 1T for laboratory magnets. Absolute uncertainty will not provide, so it will not provide a meaningful comparison as the scale of uncertainty becomes less relevant when comparing vastly different magnitudes. So uh, uh, this one is no. Okay. Fractional uncertainty. Fractional uncertainty, this is a good measure for comparing precision. When the quantities being measured differ greatly in magnitude, it because it normalizes the uncertainty to the size. So this one and this one only three and only sorry 2 and 3. Which one 2 and 3? Oh, this one C. Number 3, a runner accelerates from rest and reaches a constant speed at time t. What's the variation of displacement with time A, B, C, D? Which one? The correct answer is 1D. Why uh, A is not the solution because there is no variation displacement. Look the graph. At T, it's going, the runner take a rest. Okay, stop. And B, there is no constant. This one, no constant. This different with this one with D. And C as well, it stop. So no constant. A balloon rises at steady vertical velocity of 10 meters per second and object is released at rest relative to the balloon when the object is at high 120 meters above the ground. a resistance is negligible. What time to the nearest second does the object take to hit the ground? We will use the kinematic equation to find the time it takes for the object to hit the ground. And the equation ht equal h0 plus v0t minus 1/2 g squared. Or you can use this as a, because it's acceleration, gravitational force. Now you want to find the time t. Uh, it means we need to set, to find the time t, we need to set that ht equal 0. If h equals 0, so this equation becomes 0 equal h0. I will substitute h0 is 120 plus 10t minus 1/2 times 9.8 t squared. Okay, it's going to be 120 plus 10t minus 4.9 t squared equals 0. So this is the quadratic equation, which a equal minus 4.9, b equal 10, and c equal 120. T1 and T2 equal minus 10 plus minus square root 10 squared minus 4 times minus 4.9, 120. Scroll down first. Divide it. 2 times minus 4.9. And if you calculate, this is minus 10 plus minus square root. This one, the result is 49.52 minus 9.8. Okay. So T1 minus 10 minus 10 plus 49.52 divided by minus 9.8, and the result is minus 4.03. So this is not the solution because time never negative. 10, 49.52 divided by minus 9.8, and the result is 6.7. So this is the solution. 6 seconds. This one. C. When a horizontal spring is extended by a distance x, the force acting on the spring is F. The extension of the spring is directly proportional to the force. What is the energy stored in the spring? The energy stored in the spring is given by the elastic potential energy formula. The formula is E equal 1/2 kx squared. Right? And since the force F, since the force of F, uh, force of or F acting on the spring is directly proportional to the extension x1. So we can use the Hooke's law. The Hooke's law that F equal k times x, and then substitute k equal f for x. Substitute k f over x into this equation. It becomes E equal 1/2 times f over x squared. It becomes 1/2 fx. This one. 1 half fx. This one. Number 6. A toy, a toy collides with an identical toy car at rest. The cars stick together, the surface is frictionless. Three statements about this collision are: the speed of one car decreases and the speed of the other car increases. The total momentum is conserved. Kinetic energy is conserved. Which statement are true? One correct, one correct. This one. Only one and two. Number 7. A trolley of mass m is moving with speed u. A load is dropped onto the trolley so that it's immediately attached to the trolley. The speed of the trolley and the load becomes v. It's the diagram. What is the mass of the load? Right. In this case, we can state that the initial momentum equal the final momentum, or okay, the initial momentum m times u, the initial momentum, equal the final momentum, equal m plus n times v, the final momentum. We describe this, and v plus m v, or m v equal m times u minus m times v, or m equal m times u minus m times v divided by v, or m equal m u minus v divided by v. Which one? This one. An object of mass m is being heated by a source of constant power P. The rate of change of the temperature of object is S. What is the specific heat capacity of the object? The formula for the rate of change of temperature is P equal m times C times S. P is power, m mass of the object, C is the specific heat capacity, S is the rate of change of temperature. So if we are going to find C, we can rearrange this formula, becomes P over ms. This one. So this one. Number 9. An ideal gas is in a container with a movable piston. The piston compresses the gas rapidly. The temperature of the gas increases because when it's conditioned like this, I will sketch like this. There are gas molecules inside. Okay, so the temperature of the gas increase because as the piston compresses the gas rapidly, the gas molecules are forced into the smaller volume. When the volume decreases, the molecules, these molecules collide with each other, and the walls of the container more frequently and with greater energies. Right. So this result in an increase in the average kinetic energy of the gas molecules. So the answer is 1. Molecules bounce off the piston with increased speed. 10. A traveling wave of time period 2.0 second is moving through a medium. The graph shows for 1 instant the variations with distance of the displacements of particles in the medium. What is the speed of wave? The speed of wave or the velocity we can state to, we have to find the distance first. One. So is 1.5 meters divided by 1 time 2 seconds. 1.5 meters, 0.0 second, so 0.75 meter per second. This one, A. Next question. Source X and source Y both emit waves of wavelength 0.4 meters. There is a constant phase difference of pi radians between the sources. Point P is 5.2 meters from X and 4.6 meters from Y. The amplitude of each wave at P is A. Okay. What is the amplitude of the resultant wave at P? The phase difference between the waves due to their different path lengths is given by delta phi path equal to pi over lambda times Rx minus Ry. Delta phi path equal to pi over lambda. I would like to substitute to pi. Lambda is 0.40 times 5.2 minus 4.6, and it equals 3/2 pi. And the total phase difference between two waves is delta phi total equal delta phi path plus delta phi equal 3/2 pi plus pi, it is 2 pi. So the resultant amplitude equal square root a squared plus a squared to a times a cosine this one delta phi total 2 pi is going to be square root. This is 2a squared plus 2a times a square root 2a squared plus 2a squared becomes square root 4a squared or 2a, this one. D. An electromagnetic wave travels from medium 1 to medium 2. The wavelength of the wave in medium 1 is lambda 1. The wavelength of the wave in medium 2 is lambda 2. The refractive index of medium 1 is n. What is the refractive index of medium 2? The relationship is n1 times lambda 1 equal n2 times lambda 2. So n2 equal n1 lambda 1 over lambda 2. So this one, this one. Solution. Next question. A single pulse travels towards the free end of a hanging vertical string. The pulse is reflected. Direction of the pulse is one. The direction to downward. What is the shape of the reflected pulse? The solution is this one, towards upwards. Electric field lines A can cross each other, no, are parallel to equipotential surface, are directed from negative to positive charge, show field strength by this one. 15. What is the unit of resistivity in the fundamental SI unit? A, this is a conductivity unit, notice one. B, this is the impedance unit, electromagnetic impedance unit, this one. C, this one, the solution. D is the susceptibility unit, this one. So the correct answer is C. The correct option is C. Number 16. A cell has an electromotive force of 17.0 volt and internal resistance R. It is connected to two 10 ohms external resistor. This the first and the second external resistor. There is a current of 1.5 amps in one of the external resistors. What is the value of R? Okay, so I'm going to find the total resistance equal 1 over 10 plus 1 over 10. So total resistance equal 10 divided by 2, it is 5 ohms. And the total current 1.5 amps plus 1.5 amps. It is 3 amps. So the formula E equal I times R plus R. And we can rearrange that it's going to be E over I equal R plus R. So R equal E over I minus R. So we can determine R, the internal resistance is 17 divided by 3 minus 5, 7 ohms. Solution is C. Next. P and Q are two parallel wires perpendicular to the page that carry currents of equal magnitude in opposite direction. The current in P is out of the page. R is a fixed point equidistant from P and Q. What is the direction of the magnetic field produced at R? Right. On wire P, because of the principle of the right-hand rule, the magnetic field be directed to the left. So if you look from here, the left, it means towards upwards. Okay, because the left of wire P. And wire Q, because of the principle of right-hand rule, the magnetic field uh, towards to the right. And the result, it means this one, the solution. A. An aircraft of mass m turns in a horizontal circle. The net force on the aircraft is F. A second aircraft makes a horizontal turn with double the radius at the same speed. The mass of the second aircraft is 1.5 m. What is the net force on the second aircraft? The centripetal force formula F1 equal m v squared divided by r. This is for the first aircraft because there are two aircraft here. This is the first and the second aircraft. So for the second aircraft, the formula is F2 equal 1.5 m v squared divided by 2r. Or this is, it becomes 3, 3 half, okay? Because 1.5 is 3 half. M v squared 2r becomes 3 quarter m v squared r. So this is F1 because of this one. So F2 equal 3 quarter F1. This one. An unstable nuclide has too many protons. What is the most likely decay of the nuclide? Alpha, beta minus, this one beta plus, gamma no. The four energy states for an atom are shown. This diagram. What is the lowest frequency of the radiation that can be absorbed by the atom? If you look at the increasing, this is the lowest increasing. Okay. If E1 to E4, no. E2 to E4, no. Only E4 to E3. If E3 to E4, it means decreasing. Yeah. So must be E4 to E3. So the solution is one. This one. D. The solution is D. More than lower than others. Which Feynman diagram shows beta minus decay? A, B, C, D. The answer is the correct answer is this one, D, because we can see a neutron into a proton and a W minus boson exchange particle is subsequently decays into an electron antineutron. So you look the directions of these arrows, yeah, starting from left to the right, and at least like this supposed to be. Yeah. No, this one. No, 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 not like this one. So this is correct. Option D. Okay. Uh, the sigma power zero particle is a baryon. What is the quark structure of this particle? Uh, up, up strings. Okay. B up string. What is this one? Okay. Once research is completed, scientists gather support for the validity of their work by using common terminology, collaborating with others, improving their instrumentation, obtaining a review by independent scientists. Is 1D. Number 24. Sorry, 24. The energy sources for power stations are correct, correct, correct. Oh, it's one. 25. The surface of planet absorbs in an intensity of 400 Wm power minus 2 and reflects of 100 Wm power minus 2. The surface of the planet is equilibrium at constant temperature. What is the albedo? of the planet's surface and radiated intensity. I'm going to find the radiated intensity. The radiated intensity equal incident intensity 400 minus reflected intensity 100, and it is 300. This one 300. Oh, this one or this one. And if we divide 400 intensity, if we divide, this is albedo 400, sorry, 100 divided by, for albedo 100 divided by 400 equal 0.25 for this one. Yeah. An iceberg oscillates up and down in the sea with simple harmonic motion at time t equals 0. The iceberg is at the lowest point in its motion. At this instant, its displacement x is x0 minus x0 relative to the equilibrium sea level. The angular frequency of the iceberg is omega. What is the velocity of the iceberg at time t? Okay, the general equation for displacement in simple harmonic motion is like this: x equal x0 cosine omega times t plus phi, like this. Given t equals 0, and the iceberg is at its lowest point, so if lowest point, it means x0, lowest point t equals 0, equal minus x0. It means, so it means phi equal pi, because why? Because cosine pi equal minus 1. So displacement equation, it becomes x t equal minus x0 cosine not w, omega t. And to find the velocity, we are going to differentiate the displacement equation, differentiate this equation. It's going to be velocity, differentiations of this equation by using chain rule dxt of dt equal the differentiations of this expression, cosine omega t. So phi t equal x0 omega sine omega t. Yeah. And this one. Number 27. Light of wavelength lambda is incident on a slit of width b and forms a diffraction pattern. The central maximum has a width of theta radians. The wavelength of the light is now changed to 2/3 lambda, and the slit width is changed to 1/6 b. What is the angle between the first diffraction minimum and the point of maximum intensity? I would like to start with this the rule that sine, on this case, sine theta equal lambda over b. In this case, the width of the central maximum theta is defined as the angular distance between the first minima on either side of the central maximum. So since the central maximum spans from theta equal minus theta 1 to theta equal positive theta 1, the full width of the central maximum is becomes positive theta 1 minus theta 1, and it's going to be positive 2 theta 1. And then if this is sine theta equal lambda over b, it means sine theta xn equal lambda xn over b xn. And according to this information, this one, that lambda xn equal 2/3 lambda over bxn is 1, change 1 over 6b. And it becomes, if you divide, 4 lambda over b. I will scroll down first. Next, it means theta xn equal sine power minus arc sine of 4 lambda over beta. So sine theta xn equal 4 sine theta 1, or theta xn equal 4 theta 1. So it means theta equal 4 theta 1 minus 2 theta 1 equal 2 theta 1, or 2 theta. So this one. Technique. Monochromatic light of wavelength lambda is incident normally on a diffraction grating or slit spacing 9 half lambda. What is the total number of maxima that can be produced using this arrangement? We need to use the diffraction condition for maxima formula. Formula is d equals d sine theta, not d sine theta equal m times lambda. D is the slit spacing, and then theta is the diffraction angle, m is the diffraction order, and lambda is the wavelength. Next, if we substitute this information, it becomes d sine 90 degrees for m lambda. So it becomes, this is 1, d equal m times lambda. And according to this information, that d equal 9 half lambda, m lambda. So we can determine m equal 9 half. Okay. M, so m must be an integer. The maximum possible value of m is possible value of m are positive and negative 4. The values of m range, the range of positive negative 4, range from minus 4 to positive 4. So minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible values and so on. Source 1 and source 2 are observed by an optical system. When a green filter is used in the optical system, the two sources are just resolved. The diffraction pattern for the two sources is shown on this diagram. A blue filter is now used. What diffraction patterns will be observed for the two sources? Right. If you look at this diagram, I would like to tell you that the blue filter, according to this information and so on, the blue filter will provide better resolution between the two sources because the angular resolution limit improves with shorter wavelengths. This means the diffraction pattern will show the two sources as more clearly separated. So it will be separated between the source 1 and the source 2. And they may become more distinct than with the green filter. So if we evaluate this option A, B, C, D, the solution is 1, the answer is 1, is option D. Next question. 13. X shows the positions of a spectral line in the emission spectrum of helium from a stationary source in a laboratory on Earth. The emission spectrum of helium from a star moving toward Earth is also observed. The speed of the star relative to Earth is 0.1 c. C is speed-like. What is the observed positions of the same spectral line in the emission spectrum of helium from the star? The relativistic Doppler effect formula for wavelength I would like to write in here is lambda observed equal lambda emitted times square root 1 minus beta over 1 plus beta. So it's going to be, if you substitute this information, it's going to be lambda emitted times 1 minus 0.1, 1 plus 0.1. So it's going to be lambda emitted square root 0.9 over 1.1. And if you calculate this is, scroll down first, if you calculate this is lambda emitted times 0.9045. So the observed wave, if this is the number, the observed wavelength is blue shifted. So it will be between 500 and 600. So the answer is B. The diagram shows gravitational equipotential surfaces around two identical masses. The greatest external work is done when a test mass is moved from, okay, if you look at these possibilities, W, the W doesn't have planet orbit. So we cannot make sure when it's closer and when it's further to point X. So the solution is between Y and C. Between Y and C, Y to C between this one. 32. The graph shows the variations of the gravitational potential phi, the distance r from the center of a planet of radius r. That's the graph. A mass m is placed at r equal 3r what quantity when multiplied by m gives the gravitational potential energy of m due to the planet. From the graph, if you look this graph, we are given the variations of the gravitational potential V on this axis with distance r from the center of the planet. At a distance r equal 3r here, you can find the gravitational potential V is 3r as well. Okay, so from this graph, so we can determine that the solution, the answer is gravitational potential value at 3r, this one. 33. The escape speed from planet X is v escape speed or velocity. Planet Y has twice the density and half the radius of planet X. What is the speed required to escape the gravitational field of planet Y? We will use the formula for the escape velocity, v escape equals square root 2gm over r. The density of a planet is given, the density rho planet m over 4/3 pi r cubed. We can rearrange this formula to find m. M equal rho times, not lambda, rho times 4/3 pi r cubed. So this is mass of planet. Mass of planet is 1 rho times 4/3 pi r cubed. The density of planet Y is twice that of planet X, according to this information. It means rho Y equal to rho X. This information. And then the radius of planet Y is half that of planet X. It means radius planet Y equal 1/2 the radius of planet X. So the mass of planet Y will be the mass of planet Y will be like this: my equal rho y times 4/3 pi r y cubed, according to this information. And we can substitute this information. It becomes 2 rho x 4/3 pi 1/2 rx cubed, and it becomes 8/3 rho x pi 1 over 8, because of this one, and x cubed. It's going to be 1/3 rho x by rx cubed, because it's what divided. So it becomes 1/4 of rho x. This substitute this information, r cubed. Okay, rx, I mean x. So it becomes 1/4 mx. So my mass planet y equal 1/4 of mass of planet X. And the escape velocity of planet X, like this, v escape of X, I mean X, so square root 2g mx over rx. And then the velocity escape of y, v escape y equals square root 2g and y over ry. And it is square root 2g 1/4 mx over 1/2 rx 2g mx, because 4 times 1/2 rx, and this is 2. Okay, so 2, it means we can writing as like this: 1 over square root 2 of 2gmx over rx. And it becomes 1 over square root 2 of, this is the velocity of escape planet x, velocity escape of x. So it becomes, after that, times square root 2 over square root 2. It's going to be phi escape of planet x, square root 2 over 2. So the solution is, how this one? A circular coil of wire is in a region of uniform magnetic field directed out of the page. Refer to figure 1. This one, the area of coil in region varies with time, as shown in graph. What is the induced current in the loop plotted with time? I want to discuss graph from 0 to t half. If you look this, as the area of the coil increases over time, the magnetic flux through the coil increases. According to the Faraday's law, this will induce an electromotive force and current in the coil as well. The current will flow in such a way that it will oppose the increase from 0 to t half in magnetic flux. Since the magnetic field is out of the page to oppose the increase in the flux, the coil generates a counterclockwise current. So therefore, the current initially will be decreased and after that increase. So it means this one between 0 and t half. So the solution is 1. Next. That's 5. An alternating current AC generator rotates 300 times in 60 seconds. The dashed line shows how the induced EMF varies with time. The diagram, its graph represents the induced EMF produced when the same generator rotates 400 times in 40 seconds. The original induced EMF is shown by the dashed line. If the generator rotates 300 times in 60 seconds, the frequency is the frequency 300 divided 300 times divided by 60 seconds equal 5 hertz. And if the generator rotates 400 times in 40 seconds, the frequency is 400 divided 40 equal 10 hertz. So look that from 5 becomes 10. This means the generator complete 10 cycles in 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 10. Okay. So the frequency If 10, it means 1 to the 5 around here. So two waves from the initial to here, two waves. Yep. And then how about the frequency, the EMF? The frequency from 5 becomes 10. It means the waves from 1 becomes 2, twice. So if we sketch, it's going to be like this. Okay, like this. And the option, this one. Okay. Oh, if twice, so sorry, it means becomes the one. Sorry, I'm wrong. I have to put it like this. Becomes two waves. One wave, the first wave, this one, and the second wave. Sorry, uh, two waves. Waves, one, D, and X. So 6. Capacitor discharge through a resistor. The graph shows the variations with time t of the voltage phi across the capacitor. Given 1 over E is 0.37. What is the time constant tau for the circuit? The general formula for the voltage across a capacitor during discharge is Vt equal V0 e power minus t over tau. Okay. Tau is the time constant. E is the Euler number 2.718. Okay. At t equal tau, the voltage is, according to this information, 0.37. It is 37% or phi tau equal phi 0 times 1 over E, or phi 0 times 0.37. Okay. On the graph, 0.37 around here. Okay. So it means the time around here. Right. So the solution is, the answer is this one impossible, this one no, this one C. For 10 μF capacitors are connected like this, series, series and parallel. This is what is the capacitance between P and Q. First, we need to calculate this one. Parallel. If parallel, it means 10 plus 10. So the circuit becomes like this. This is 10, 10, this is 20 because 10 plus 10 here. So if 10, 10, 20, we can calculate the capacitor 1 over C total equal 1 over 10, 1 over 10, 20. So this is 2 over 20, 20 plus 1 over 20. It is 5 over 20. So we can determine total capacitor, the total capacitance, I mean, total capacitance equals 20 over 5. It is 4.0 mu farad. What B. C8. Electrons are accelerated through a potential difference and are incident on a sample of crystal atoms. causing a diffraction pattern. When the potential difference is increased, the maxima A are close together, are farther apart, have a similar intensity as one. 39. An electron exists in an excited state for about 10 power minus 10 seconds. What is an estimate of the minimum uncertainty in the electron's energy? The energy time uncertainty principle is given by the formula delta E times delta T greater than or called hour, and it becomes delta E times this is 10 power minus 10, okay, 1.055 times 10 power minus 34. So it means delta E greater than or equal this number times 10 power minus 34 divided by 10 power minus 10. So pay attention for this number becomes minus. So it's going to be delta E equal and greater than or equal 1.055 times 10 power minus 24. Okay. So one electromotive force, one electron volt, I mean, equal 1.602 times 10 power minus 19. So we can we can convert this number into electron volt, becomes 1.055 10 power minus 24 over this one, 0.602 times 10 power minus 19 electron volt. So rounding to reasonable number of significant figures, we get that delta E greater than or equal 10 power minus 5 electron volt. So this one, D. For T, the radius of a nucleus of a particular nuclide X is 4.8 femtometer. What is the nucleon number of X? The formula R equal R0 A power 1/3. So we can rearrange this formula to determine A. A equal R over R0 cube. And after that, substitute, this is 4.8 femtometers by 1.2 femtometers cube. And the result is 4, because if you simplify it, it becomes 4 cube. It is 64. This one. Done.